Good morning, guys. Today we are starting a conjugate beam method. So, what is this conjugate beam method? What exactly this method called as? The conjugate beam method is to find out the slope and deflection for the determinate structure. We already know what is determinate structure and indeterminate structure. So for this determinate structure, we need to find out the slope and deflection. To find out the slope and deflection, we have lot of methods, that is moment area method, double integration method and conjugate beam method. So here we are going to study about the conjugate beam method. The conjugate beam method is the one of the method to find out the deflection and the slope for the given beam. Today I want to tell you the introduction about the conjugate beam method and how to solve the problem to find the slope and deflection for the given problem. Guys, before that, in this method we are going to understand a single concept, that is the load which is acting on the beam is related to the moment acting on the beam due to loading, and the shear is happening due to the load and the moment. So this is the important circle which interrelate the load, moment and shear. So shear is the internal function of load, that is V of x is equal to integration of W of x dx. For example, this is the beam. A UDL is acting on a beam which load of W of x with the length of L. So we draw the SFD, this is the shear force, and this is the BMD, that is bending moment diagram. So here you can see this, the shear force V of x is equal to the single integral of load, where the moment, that is the bending moment, is the integral of shear, that is double integral of load. Means what we understood here, the slope we call as the integration of m by ei dx. What is that? The slope, where theta x is the single integration of m by ei dx, and deflection, that is yx, that is double integration of m by ei dx square. Now what is this? Why I am explaining this? What is theta and yx? The theta is the slope and yx is the deflection. Now you just interrelated this. The single integration is nothing but the Vx, means the theta is equal to the shear force of the given beam, and the deflection is the bending moment of the conjugate beam. So now I go to the concept. The problem which is given as a questionnaire, that is the real beam. In the conjugate beam method, we have the two types of beam. One is real beam, one is conjugate beam. The conjugate beam I will tell you later. Now real beam. What is real beam? The real beam is nothing but the load with having the supports, and complete the questionnaire. The questionnaire which is given in the question paper, that is the real beam. First we need to find out the shear force and the bending moment and draw the bending moment for the real beam. And that bending moment diagram is converted to M by EI diagram, where EI is called as flexural rigidity. So for this real beam we got BMD and MI-EI diagram. Then what is conjugate beam? The conjugate beam is the beam which carries the MI by EI diagram as a load case. Now you can see this. This is the conjugate beam. This is the real beam. On above real beam, the M by EI diagram is acting as a load. Now what is conjugate beam? The conjugate beam is the beam which carries the load as the M by EI diagram of the real beam. Okay, what is this? Easy to calculate. Now Now M by EI diagram, it is there as a load case, and for the given beam, that is the conjugate beam. Now you need to find out the shear force for this conjugate beam and bending moment at the point we want for deflection, that is we want the deflection of the real beam. Okay, now I go back to this. Now theta x is equal to integration of M by EI diagram, means M by EI diagram means shear force. So in the conjugate beam we need to find out the shear force acting as a slope and bending moment at that point acting as a deflection of the real beam. Means if you are finding the bending moment at the conjugate beam, that point is nothing but the deflection of the real beam. Thank you guys. Now after understanding the concept, now we go for some conditions in the conjugate beam. Before that, now you can see this. This is the cantilever beam of length L. This is the real beam he has given in the question. The slope and deflection we need to find out. Now what is the conjugate beam? See this, the conjugate beam, it is in the next right hand side, where this is the condition that which is going to explain in this. For this beam we need to find out the shear force at point B and the bending moment at the point B, which is turning about the slope and the deflection. Now you got, I think so guys. In the real beam, the deflection and slope, what is the equal to the conjugate beam of bending moment and shear force at that point. Okay, now see this, slope at fixed end and deflection is 0. Same thing here. Free end, the shear and moment in free end is also 0. Now what you understood? The slope is equal to shear here, deflection is equal to moment here. Okay, now what is the conditions? Now we are divided into the two parts. One is real beam, one is conjugate beam. One is real beam and conjugate beam. Real beam is nothing but the question paper. Okay, the